Yeah, I just wanted to amplify on the cost of goods, back to betting on the engineers. The cost of goods to make an autologous genetically engineered cell today is quite high. But there are so many easy ways to change that. I mean, I'll give you one example, lentiviral vector, which is the vector that's used to modify T cells. Historically, that was made in little plastic containers in very small scale, and it was stuck to the plastic. Now you can make that in 100-liter bioreactors, think brewing beer. It brings the cost of that component down 95%. And you can just apply that mindset to everything about the manufacturing process. Automation, a lot of the cost is people. You can automate that. So I think cost of goods has a very easy line of sight to drop it by 90%. That starts to get into the more traditional pharmaceutical type product cost of goods. Then you brought up just complexity and patient access. These cells have to be given in special centers of excellence. When they first launched, there was a limited number of centers of excellence. Now there's an ever-growing number of centers of excellence, and managing the side effects is not as hard as people think. My daughter just graduated from medical school. She rotated through the CAR-T inpatient infusion unit. The next generation of doctors are going to know how to give these therapies and manage the side effects, and then the FDA will back off on the requirements that you have to travel to a center of excellence and stay there for a month. I mean, that's hard for people. That minimizes access. If you can bring these products into the community, if community doctors get comfortable managing the patients, you can imagine patient access will improve. So cost of goods will come down, patient access will go up. I don't think those are the hardest problems. The hardest problems is the challenge of cancer biology.